Good afternoon, dear friends. I welcome one and all for Saturday's webinar session by Hello Kids. Today we are going to learn about STEAM for preschoolers. To know more about this, we have our guest, Mrs. Kavita. She is a tech SDGs ambassador, climate action ambassador, and scientific ambassador for India. She has conducted many action researches and has awarded the Global Teacher Accreditation by British Council in 2014. She is a British Council trainer and ambassador. She is a member of Cambridge South Asia Advisory Board. In 2016, she was nominated as Top 50 Teachers by Varkey Foundation for the Global Teacher Prize Award. In 2020, she was awarded Iconic Principles by Governor of Maharashtra. Welcome to Hello Kids, ma'am. Over to you.
Thank you so much for having me, and thank you to Mr. Preetham for inviting me and the entire team of Hello Kids. So, I will share with the presentation for exactly what STEAM actually means, STEAM for preschoolers means. So, great. So, when we talk about STEAM, what is STEAM? And let's see, understand why STEAM is so very important. Now, in our country, the world that we live in, there are very six drivers which are changing the entire world. The first driver that we speak about is increased longevity. Now, all of our lives have really increased. We're becoming, it's no more that you're, going away at 50 or 60. You have people moving on to working till 80 and 90. So, therefore, we'll have to move away from the traditional career paths and organizations and have more diversity, more adaptability, and flexibility in our career work. Second thing that we mostly watch is the rise of smart machines and systems. And we've already seen that across. Artificial intelligence is a very integral part of our life. So, therefore, we need to have new expectations and standards of performance having across. We will need to have a partnership with machines. This machine is going to be working in your home, and you're going to be having an actual conversation with that machine, and maybe the machine is going to ask you, how was your day? So, that is some kind of bonding that we're going to be having with the machine. So, how are we going to working on building the mutual strengths of each other? The third thing that we've noticed right now is a computational world. Now, if you've noticed, everything is on sensors. Now, even when they take your temperature, they just take a temperature sensor and they note that your temperature is, normal, or is it you're feverish, or it is below that. Everything has become based on sensors. So, if they know sensors, it's becoming a programmable world. Now, think about it. On Facebook, if you have gone to a particular advertisement, you've liked something, and next day you find similar kinds of ad coming out. Hasn't somebody sensed that you are particularly going to that site, and then the things are coming across more and more to allure you? That is nothing but machine learning. So everything is becoming data. Whatever you are doing is becoming data. And that data is everything which is going to turn into a program. So the world is now going into a computational world. We now have super structured organizations. When you talk about that, the organizations are something which is going to create new forms of production and value creation. It's no more like small structures. It has become now large global structures. Earlier, school was within itself, but now schools are networking with schools across India, across the world. So there are global projects taken across, global tasks taken across, and that is becoming a super structured organization. Now, when we talk about global connected world, we all know that anything that impacts in one part of the world, it gets impacted every single place. So now with the Russia-Ukraine war, we know the price of petrol has gone high in India. So therefore, it's a globally connected world. It's going to become a business of multinational powerhouses. What are we going to be doing about it? Then we have new media ecology. That means you've seen the kind of work that's coming across to us. We're requiring new tools of media literacy. The way you and I are connecting right now, it's using new media. So your media kind of language is going to change. It's no more like if I have to ask you, do you like it? Your single like tells me that you have liked something about it. So therefore, our entire language has changed. And if all this has changed, then what is it that is driving all of this? It's nothing but steam. All this is being driven by science, technology, art. It is talking about engineering. It's talking about mathematics. So STEM plus art is basically your STEAM that we are talking about. Now we've already seen about people talking about, yes, we do science, yes, we do mathematics, yes, we do art in school. But have we actually brought it together? Have we amalgamated all the subjects together to offer STEAM learning? So when you talk about yourself right now, have you ever wondered how is it that I'm sitting in a school in Mumbai and maybe you are sitting in a school in Bangalore? And how is it that you are able to hear me? Have you ever asked yourself that question? What is it that's actually working behind this? You have a device, I have a device, but how is that one device connecting to the other device? Have you ever questioned it? And if these questions are what we want our preschoolers to ask, so when we talk about STEAM, I'm not talking about, oh, the students should know about, artificial intelligence, the meaning of it, the making of it. No, I'm asking them to ask questions. How is this working? How is it happening? Why is it happening? So them to know awareness of what is happening around them. And that STEM is everywhere. So let's go into how we can produce and inspire students for STEM learning. And to do that, we have to start working on ensuring that we're building the life skills of our students for STEAM learning. And these skills are what is going to promote our entire STEAM building in our classrooms. I'm sure that all schools are doing a lot of communication and collaboration activities where students are talking to each other. There's a lot of creativity and critical thinking where you're asking higher order thinking questions using Bloom's taxonomy. Maybe you're even allowing students to take responsibility of themselves in the class, maintaining discipline. Maybe you're asking them to create a new art object. Maybe you're asking them to participate. Maybe you're asking them to take a decision. Will you eat this today? Will you not eat today? Will you stand in a line? Will you not stand in a line? You're asking them what is it you wish to do tomorrow? What is it how you want to dress? What is it that you wish to study? You're asking them to simple questions. You're asking them maybe solve a simple questions. You're asking them about life and career, which will come later on. But maybe looking at the different people around them in the family, maybe a family of doctors, a family of creative people who work on computers, or maybe somebody working in media. You're looking around them. Is this what you wish to be in the future? Are you liking what I'm doing right now? Or technology and information media. So these are the life skills which we want to build through STEAM learning. And so how are we going to go about it? Now, the first thing that we can start as parents, as teachers, as students is to start working with computational skills. And it's something that can be done at home. A simple activity is on your respective tiles, put in maybe any kind of object. Say, I have put in right now soft toys. And I've asked the students, you are standing at a particular place, you have to reach that particular soft toy, say a monkey. How are you going to go ahead? So the child says, I'm going to walk maybe 5 steps forward. So you write down to the child, I walked 5 steps forward. Now you need to go from the monkey to maybe another soft toy. And now you say from the monkey to the other soft toy, how are you planning to go? Now you can only go in straight lines. There can be no other lines. Maybe either you go in 90 degrees or whatever it is. Again, the child will say, I walked 1 step forward. I then went 2 steps right. Now, what are you doing with that? You're actually making the child slowly do programming. You're making the child write down steps for programming, which is the basic level for preschoolers. But you've started making them think logically through that. So, anytime that they have to do a problem, they start thinking logically. I am here, I am starting here, I need to reach so and so position. How do I progress? Am I going right? Am I going left? Am I going forward, backward? And then I'm putting it down as points, bullet points. One step follows another. So there's a lot of logical, systematic thinking happening out here, which can happen anywhere. In your house, you can do this. You can even do a similar activity where you have directions put across on the floor. Say maybe you have said one tile is start, the other step is at the end, and every tile you written go 2 steps forward, go 3 steps backward. So you kind of play a snakes and ladder game here itself, and then have them play this with their friends, and then again note down what happens when you're doing this, what happens when you're doing that. And this simple computational skill is nothing but the basis of coding, which is so important in our students, for our students to create. So this is how coding skills can be built in our preschoolers, and that is the fundamental. And after this, I'm sure you have much more better ideas than I do at present to start with computational skills in our students. Now, when we talk of art, you're seeing the students here right now dabbling with a couple of things, and you've done all schools to a lot of art. But how do we connect it to daily life? So maybe you take this kind of drawing, and then you ask the student, okay, now I want you to stand maybe 5 steps behind. And tell me, which color are you able to see more clearly? Take them now 10 steps behind. Which color are you able to see more clearly? Maybe 5 steps, they said, both I can see clearly. 10 steps behind, they say, I can see the red more clearly. So they'll have noted down which color you saw more clearly at a longer distance. Start with simple experiments like this, where you're connecting your art to your STEAM thinking. And slowly later they realize, oh, this red color is something that I can see at a larger distance. And that is why all my traffic signals, all my stop, all my major signs are all red in color. So then they start connecting it to why it is red in color. So it's small things like art. Even when you talk about different kind of art, we say with the brinjal they're drawing, or with a lady finger they're drawing or something, and maybe show them a monument where some part of it was shown. They start connecting that to respective monuments and say, oh, I did this in class today, and I saw this drawing in that monument. Wow, they're correlating it to a monument. And that maybe that monument is somewhere placed in Delhi, the monument is placed in Jaipur, but you are connecting it again in your class to something different. Or something like they have created some nice skirt, and then you have a fashion show happening across site, and you say, this is what you have designed, and see this dress is being worn by this model, and then this fashion show is happening in Italy, Milan. Where is it? Let's find out on the globe. So once again, you've taken a small, simple activity. You're doing the same things, but you're connecting it to something STEAM at a higher level by just asking those basic questions. Now, when you talk of technology, that's so very important, because in the COVID period, it is technology which connected you to me. So obviously, I know that all of you all are very well versed with technology, using your computers, using your smart boards, where you say that I want to do something with, connecting with the words, and the child real is shown that the word is lamp. But when we talk of technology, I would rather ask you, at home you have a language that you use. For example, you say, I send a mail to somebody. Talk to your child also using that kind of language. Say that, I did receive this information from your school through an email. So then the child says, yes, you got a mail. Do you know how this mail works? So maybe I have a Google account, maybe you have a Microsoft account, so you have a different account. So when you talk of this term, basic terms of technology like we have this modem working, the server, maybe the server is down, or maybe when you're driving the car, I'm using GPS. They don't need to know exactly how GPS works, but you're talking to them about this entire terms, which then later on starts building in the future. So what you're basically trying to do is you're going to spark curiosity in the child. This is GPS, is a global positioning satellite. Or I'm not able to do this because my bandwidth is not supporting me. We can exchange information if there's Bluetooth happening across, Wi-Fi, or maybe you're just talking to your people and just talking, I'm using this mobile, but I'm not getting network. Maybe the satellite systems are down. So you are using these terms in your day-to-day conversation with the students. So bringing the scientific terms in the conversation. Let them not go in deep into resisting, but at least they've heard these terms so that when they go to the primary and secondary, if the teacher is talking about satellite, they're talking about Wi-Fi, they know that I have heard these terms. And they're connected with something to my technology that I'm using right now to connect with the teachers across, during COVID periods and used across, or right now for blended learning or hybrid learning. So I would rather that you start using this terminology in with your students, and that's technology that we need to work on. Now we talk of engineering skills. Engineering for preschoolers is very, very important because they are that the gross motor skills are building up. So you can have them really use Lego blocks or then clay or something and just feeling a couple of things. The senses are very important. So when they're building that engineering skills, they're building a home, a building. You've seen the child here making a house. You've seen the child here creating a building. The simple thing, when they make that building, ask them remove the block from the bottom first. What's going to happen? I'm sure you know that it's going to completely fall down. So then you can ask them what happened? Why did it fall down? The child will have his own language, know something not stable, support, but they use the word support, stable. That's enough for them. So that means the base has to be there. The top can be removed first, but the base has to be there till the very end. So they realize that the base is the most important part. And that builds the entire foundation for any engineering work that happens. And then talk about when you're driving around, right now, there are metros coming up everywhere. There are buildings coming up everywhere. So then you're walking around, you tell them that what is it you're observing? What is being built first? So it is nothing but the right type of questions that you ask and then connect it. Connect what is done in class to what is that they're seeing outside. So therefore they realize why in buildings, when they're making buildings, why are they going deep down first and then working on building things up? Why are they going deeper and deeper? The bigger the building that you want to make, the more deeper you go down. So that small connections is what we want our children to have. So with Lego blocks, with Minecraft, with kind of houses that they build, with clay things, or even with sand monuments, what happens if I first break it down? Or maybe you can say from the top. Now you have made this building. Now from the top, remove one block and put it on this side. How is it changing? How is it looking? How is it feeling? So ask them to experiment with the same Lego blocks and do new things. And let me tell you, it's not difficult. Don't think that because they're too tiny, they cannot do it. They can do it. Just don't give pressure on them. Just let them be. They and I are much smarter generation than you and I. So we just need to have that kind of expectations that yes, if left on their own, they're going to be more curious, they're going to be more experimental, they're going to be much more and better than us. Now, these are simple science experiments that we do in class, and I'm sure everybody is doing it across. So, the first experiment, you see the different jars that the student has right now. Now, what has the child done across? We have done nothing. We've just taken beakers. We put four different paint colors there. So, we told the children, just take any four colors of your paint and just add it to the water. The children conducts it. Child conducts it. Then we said, just now add some soap solution to it. Take a straw and now take a paper and just blow through it. So when they blow through it, they see different colors coming on that paper, and then they play across with that colors. So when we see that, we ask them, when we first did not put soap, were you able to blow through it? Now when you put soap, you were able to blow through it. What happened? So they realize that when you put soap, it becomes frothy. It's easier to blow, and that just that much understanding is enough for them. You have maybe a telephone wire where the students are hearing and talking to each other. So you're saying how sound is being produced. Oh, hello, hello. Can you hear me? Yes, I hear you. How are you able to hear me? Or maybe just take the same setup and do it from two different rooms. So this kind of thing is how is sound passed on. The third, you can see right now, I have children playing with what is sink or float. We have a variety of objects on the table. When you ask them, put that object, now is it going down or is it staying above the water? Is it between the water, half the sink? And the students write down, yes, they're sinking or they're floating. Now, once they know what is sinking and floating, we ask them to connect it to daily life. So, daily life, in a sense, for example, when you go swimming, how do you go? What is your position? So they say, no, when I'm doing swimming, I am horizontal. So then why not vertical? So then if I go vertical, I might sink. But if I'm horizontal, I will float. So now that simple connection of sinking, floating. Why? Because weight will be more or less. They may not use the word weight. But then, yes, I become heavier or lighter. So these small conditions, when you start thinking students in terms of, connecting it to daily life, these experiments become a part of your daily life. Then things, when they come to STEM learning in the primary, they really take it up, they latch it up very easily. It's no more a complex topic. It becomes something where they're seeing it to amalgamate it together. So they don't see it, okay, this is a science subject, this is a mathematics subject. No, this is STEM subject. I'm seeing it all in one frame. So when I do about these experiments, I'm talking about when she's blowing it out, I'm talking in terms of maybe say even the aesthetic part of it. How is she doing it? Or even she is doing it to a straw. I'm asking them, how is it that to a straw she's able to suck it and get it and put it out? So some idea that they have, some experiments that they have done will always get applied later on. And finally, I would just like to say, if you wish to desire fathoming a complex subject, start teaching it to a bunch of exuberant students. Let me tell you, once you start teaching children who are curious, who are excited, nothing can stop them. And automatically, STEAM is no more something complex, it becomes something which is becoming an integral part of their life. So when they're sitting with you, maybe they'll just tell you, Mama, this table, what is this table made up of? And you can tell the table, oh, this table is made of wood. Where is this wood coming from? Or what does the table have four legs? Why not two legs? So questions like this can get them thinking. That's all I could say is that I'm sure you'll have a lot of STEM questions. Most welcome to send it across, and I'll be very happy to answer it. And I wish you a journey of STEM learning. Thank you so much. So thank you to Hello Kids for having me around. Thank you so much to everybody.